Hello everyone, welcome back to the series on Indian mathematics, Ganita Ratna Kosha. In this video, we will look at osculation process for divisors ending in 1. Now, one way to find the osculator for a divisor ending in 1, for example, if I had to test divisibility by 31, I can multiply this by 9 to get 279 and take osculator as 28. Now, osculation process with 28 might become a little difficult. So, what we do is we can do the process with 28 as well, and we will eventually get the result whether it is divisible or not, but we will not do that, and we do something called as a negative osculator with a slightly modified process. Now, in this case, let us call that OS bar. Okay. For 31, OS bar is just 3, drop the 1 and just 3. So, we will work out the osculation with a negative osculator with the negative osculator being 3. Similarly, if I have 41, then OS bar will be 4. If I have 81, OS bar will be 8, and so on and so forth. It is just the digit or the number preceding 1 in the divisor. Now, let us see what is the slightly modified osculation process. So, let us say I was trying to check divisibility of 6603 by 31. I will use the negative osculator, in this case it is 3. So, because I am using the negative osculator, I will mark alternate numbers from the right, starting with the second digit as negative numbers, put a bar on top, they are negative numbers. So, in the osculation process, I will subtract these numbers. So, let me start the process. So, first step is 3 into 3 minus 0. So, that is 3 into 3 minus 0, which is 9. Then the next step is 9 into 3, 9 into 3. Now, 6 is a positive digit, so I will add it. 9 into 3 plus 6 is 33. Now, when I have 2 digits, unlike adding the first digit to the product with the oscillator, I have to subtract it. So, here it is 3 times 3 minus the first digit minus 3 and minus 6, because this is a negative, I put a bar. So, this is 0. Now, 0 is divisible by 31, and hence this number 660 is divisible by 31. So, this is a modified process with a negative osculator. Now, this avoids all the big multiplications we would have had to do with 28 otherwise, and we make sure that we mark the alternate digits from the right, starting the second digit as negatives, and the other change is when we have 2 digits in one of the results, I have to subtract the digit in the tens place. So, using this process, let us do a couple more examples, so that the process is clear. Let us say we were checking divisibility of 1, 1, 2, 3, 4 by 41. So, my OS bar or negative osculator is 4 in this case. Now, I mark alternate digits as negative and I can start the process. So, first is 4 into 4, 16 minus 3, so that is 13. Then it is 3 into 4 minus 1 and plus 2, so that is also 13. Then again 3 into 4 minus 1 and then minus 1. So, 12 minus 2 is 10. Then 0 into 4 minus 1 and plus 1, that is 0. So, since I got 0 again, so this is divisible by 41. 0 is divisible by 41 and hence the given number is divisible by 41. It is actually much simpler than doing osculation with the positive oscillator, as long as you are comfortable dealing with the negative numbers in between. Let us look at one more example. If I was doing 4, 3, 7, 3, 2, 1, checking for divisibility by 51, my OS bar in this case is 5. So, first step 5 into 1 So let me just mark the negative so that I don't forget. So 5 into 1 minus 2, that is 3. Then 3 into 5 plus 3, that is 15 plus 3 is 18. Then 8 into 5 minus 1 and minus 7. That's 40 minus 8, that is 32. So 2 into 5 minus 3 plus 3, that is 10. And 0 into 5 minus 1 minus 4, which is minus 5. Now minus 5 is clearly not divisible by 51. 5 is not divisible by 51, hence this number 437321 is not divisible by 51. So this is the process for checking divisibility using a negative oscillator, and it's very useful when the divisor ends in 1. I've given some problems to try in the notes. Please do try them out, and you will also find the workings on the website. For any clarifications or suggestions, please do write to me. Thank you.